Hi everyone, my name is Yi. I'm very honored to be here and introduce our work, STiL, Semi-supervised tabular image learning for comprehensive task-relevant information exploration in multimodal classification. Structured tables are increasingly available in real-world multimodal datasets. Integrating tabular data is crucial in various applications, such as commerce and healthcare. Therefore, developing image tabular representation learning methods is receiving more and more attention. One of the key challenges for image tabular learning is limited label data, especially for classifying rare diseases. Prior works proposed self-supervised learning and supervised fine-tuning. However, they still suffer significant performance drops when labeled dataset size is reduced, since their pre-training is task-agnostic and their fine-tuning may encounter overfitting. Semi-STiL is a promising direction which combines a few labeled and a large amount of unlabeled data. Current multi-modal Semi-STiL can be categorized into two directions. Cross-modal consistency regularization methods focus on learning cross-modal invariant representations by enforcing consistency constraints across modalities. Co-pseudo-labeling methods use the predictions from unimodal classifier 1 to supervise unimodal classifier 2 and vice versa. However, they encounter bottlenecks in real-world applications. Take the image tabular learning as an example. Task-relevant information is contained in both modality-shared and specific characteristics. Thus, relying solely on modality-shared or unimodal features will cause incomplete task understanding, a limitation we term as modality information gap, and prior works fail to address this gap. So, how to comprehensively explore task-relevant information with limited label data and address the modality information gap? We propose STiL, a new Semi-STiL tabular image framework, including a novel disentangled contrastive consistency module to learn modality-shared and specific representations, a new consensus-guided pseudo-labeling and prototype-guided label smoothing strategies to exploit task-relevant information from unlabeled data. STiL first extracts image and tabular representations through two separate encoders, then leverages DCC to decouple and learn modality-shared and specific information from labeled and unlabeled data. For labeled data, STiL calculates the classification loss using ground truth. For unlabeled data, STiL leverages CVPR to generate pseudo-labels based on classifiers' consensus collaboration, and refines them with prototype similarity scores in PGLS. These pseudo-labels are used to extract task-relevant information from unlabeled data. DCC proposes to learn cross-modal invariant features while returning modality-specific information through constraints. The disentanglement constraint minimizes the mutual information between the shared and specific representations. The shared information constraint enforces the image and tabular representations from the same subject being closed. The second part is an inter- and intermodality interaction module, which enhances unimodal and multimodal representation learning. In CVPR, we propose a rule-based strategy for reliable pseudo-labeling, which uses the alignment between the multimodal and unimodal classifiers. To avoid the classifier collision during training, we propose a selective classifier update to allow classifier diversity. In PGLS, we use feature-level label information to refine pseudo-labels, including class prototype extraction, prototype contrastive clustering, and pseudo-label smoothing. Finally, our overall loss contains 4 terms. We study a medical dataset for CD and infection classification, a natural image dataset for model prediction. The results show that STiL significantly outperforms supervised and SSL SOTAs. STiL also shows remarkable improvement compared to earlier Semi-STiL SOTAs, which do not consider the modality information gap in multimodal tasks. Our various ablation studies demonstrate the efficacy of our proposed model components. Our case study also shows that STiL can handle challenging cases and minority classes with very limited labeled samples. That's all. Thank you for your listening.